Hey everybody! Today we're going to talk about the segment addition postulate. Ow, ow, ow! Alright, so we are going to use the segment addition postulate in a proof. Okay, and we're also going to find the length of a segment using the segment addition postulate. Alright, so I want to do a little bit of comparing notation before we talk about the postulate. So, for example, if I want to say a line passing through points A and B, oops, I don't want a picture, it's been a long day. Okay, I want to say line AB, okay, and I need the little arrows on that bar. All right, now, if I only have one arrow on one end of the bar, okay, remember that this is a ray. And it has an endpoint at A. And then it goes forever in the direction of B. B direction. Okay, that's a ray. All right, if it's got no arrows, if the bar has no arrows, this is a segment. Oops, segment. Okay, now I've been hounding you, saying you have to remember your arrows. You have to remember to put a bar on it. And it's because of today. So finally, we're going to learn what it means if we just write AB without the symbol on top of it. So if I just have AB, it means something totally different. Okay, it means the measure or the length of segment AB. Length. Okay, now you probably noticed that I did these three in orange. Okay, they all have something in common. These are all figures, geometric figures. Okay, they're not really shapes, but they're figures. We can draw them. Okay, AB without a symbol on top is not a figure. It is a value. It is a number. Okay, whole different can of worms. Okay, so hopefully that cleared up for you the differences in some of the notation and will make today easier. Just a reminder about what a postulate is. Okay, a postulate or axiom is a statement that is accepted as true without proof. Okay, it's so basic, we can't really prove it, but we can use it to prove other things. So you guys are gonna like this. It's pretty simple. If and only if point B is between point A and point C, and like between we mean like on the same line as, so they're all collinear. Okay, that means that B is found on the shortest distance between A and C. Like it's not saying A is here, C is there, and B is up here. That is not between, okay? This is between, okay, not this. Okay, perfect. Okay, if it's between A and C, then we know that the length of AB plus the length of, BC, so this length plus this length has to be the total length equals the length of AC. The whole shebang. Okay, so to put some numbers to this, if I tell you that AB is 5 and that BC is 8, we know that the whole thing is 13. They should add up to 13. If they don't, they're not in between. B is not in between. Okay, now you might have seen this crazy little if. This crazy little if, we're going to talk about it for a second. That's not a typo. If with two F's means if and only if, which means that that statement is true going forwards or backwards. So I can either say, because B is between A and C, I know that these have to add up to the total, or I can work backwards and say, if these add up to the total, then I know that B is between. So I can work it backwards or forwards, and we'll see that in a minute on examples 2 and 4. So stick with me. All right, look at example 1. Point G is between F and point H. So we're going to draw a picture. So here's my segment. Okay, here's point F and point H. Now, this doesn't have to be to scale. And G is in between. Okay, it's telling me the measure of FG is 6. So this length right here is 6. And it's telling me the measure of FH is 11. Oh, not GH. I was trying to write it here. It says FH. So this whole thing is 11. So I definitely didn't do this to scale. Okay. Maybe it'll help you if I kind of do a little bit. Here, let's move this. Let's redraw my segment. All right, I can do better. Okay, so let's put G here. Okay, this is going to be 6, and this is 11. So what does GH have to be? We know G is on this segment. What does it have to be? Well, 6 plus GH has to equal 11. So maybe we can write a little equation. 6 plus GH equals 11. Subtract the 6 from both sides. And we get that GH is 5. Ta-da! Okay, and sure enough, if I take 6 and 5, add them up, I get 11. All right, look at example 2. It says that QR is 6. The measure of segment RS is 14, and the measure of segment QS is 20. So we want to know, is R between point Q and point S? So we need a picture. Okay. I want to know, is R in the middle? Here's Q. Here's S. It's saying QR is 6 and RS is 14. If R is in the middle, they should add up to 20. So because these segments add up to 20, we can say R is between point Q and point S. So we can say yes. Okay. Let's try another. All right, point Y is between point X and point Z. X. Oops. Y. Z. Okay, XZ is 3. So the big total is 3, and xy is 4/3. Okay, 4/3 is 1.3 repeating, so it's like 1 1/3, a little bit more than 1, but not quite 1 1/2. All right, we have to draw a picture. We did that, and then we have to find yz. So we know that 4/3 plus yz equals, you know what? I think I did lowercase letters. I'm sorry about that, guys. My algebra is showing. Okay, this is a capital X. This is a capital Y. This is a big Z. Okay. I think I did it here too, didn't I? So Y, Z equals, okay, so our 4/3 plus YZ has to add up to our total XZ, which is 3. Okay, so we are going to subtract the 4/3 from both sides. These cancel, and okay. So, guys, if we subtract 1 1/3 from 3, we're going to be left with 1 2/3, which is 5/3. 5/3. Okay, so YZ has to equal 5/3. I'll write that on here. And if you're like, I don't believe you, I'll show you. If I have 4/3 plus 5/3, I keep my denominators and I add my numerators. 4 plus 5 is 9, and 9 divided by 3 is 3. Okay? So, yes, got it right. All right, example 4. TU is 8, UV is 11, and TV is 17. And we want to know, is point U between point T and point V? So we don't know. We're just going to draw some question marks. We don't know. We are told that UV is 17. Okay, UV, whoops, I did that wrong. Hold on. TV is 17. Let me fix my picture. TV is 17. U is in the middle. TU is 8. UV is 11. So do 8 and 11 add up to give us 17? Spoiler alert, they do not. They add up to 19. So what's happening is that this is not the arrangement. It actually looks like this. Here's T, here's U, here's V. Okay, the distance between T and V, this is 17. It's shorter than the 8 plus 11. So we can use the segment addition postulate to say there is no way that U can be on the same segment as TV. It can't be between them on the segment. Okay, so we're going to say no. No. All right, next. We're going to do some proofs. Okay, so we have to do a couple things. Here's our picture. You can see that point E is between point D and point F. That means we get to use the segment addition postulate. Okay, we also have to find DF. That's this total length. Okay, that's what it says right here, find DF. So we'll do that at the end. I'll show you how. So the first thing we have to do is tell all of the stuff that we're given in the problem. So the first thing that we're told is DE. The measure of DE is equal to 3x minus 1. I just got that from the picture. 3x minus 1. The second thing we know is that the measure of EF is 13 from the picture. Measure of EF is 13. Okay, now I also know from the picture that the measure of DF is 6x. So DF is 6x. And how do I know all that stuff? Because it was given to me by the math gods. So I just write given. Okay, the next thing I know is that the length of DE plus the length of EF has to add up to the total DF. And that is the segment addition postulate. So I'm going to put that in next. So DE, the length of DE plus the length of EF has to add up to the length of DF. Okay, that is the segment addition postulate. Okay, now it's not going to do me any good to solve this equation because there's too many different letters in it. But if I can plug a bunch of other things in there that all have the same one variable, then I can solve that equation for that variable. So that's what I'm going to do. I'm going to get everything in terms of x by using substitution. So for DE, I'm going to put this, 3x minus 1. Okay, for EF, I'm going to put 13 plus 13. Copy down my equal sign. For DF, I'm going to put 6x. Okay, I just replaced each of those with an equivalent expression. That is the substitution property. I literally substituted. Okay. Now, I have some simplifying that I can do. I have a negative 1 and a positive 13. I can replace that with something equivalent. Negative 1 plus 13 is 12, so I'm going to substitute in 12 for negative 1 plus 13. So I've got 3x plus 12 equals 16x. That is also the substitution property. Okay, your algebra teacher called it combining like terms. So in parentheses, just put CLT. All right, now we want our x's alone to figure out what they are. So we have to subtract this 12 from both sides. Whoops, just kidding. Our x's are all over the place. They're on both sides. Okay, so the fastest way to get x's alone is to subtract away the 3x from both sides. So let's do that. Subtract 3x, subtract 3x. These cancel, and I get 12 equals 6x minus 3x equals 3x. That was the subtraction property of equality. Okay, last but not least, we have to divide both sides by 3. Okay, that gives us 4 equals x. That is the division property of equality. Okay, now, if you're anything like I was when I was a kid, I've already forgotten that at the very end of this problem, I'm supposed to find df. Okay, it's very easy to do. So the way that we find df is that we plug it in. Remember that df equals 6x. But guys, guess what? Now we know what x is. X is 4. So we can use our substitution property and just take the 4 and plug it in for x. So we get 6 times 4, which is 24. And that's df. Here, let's write it over here so it's neat. df, the length of df is 24. Box it up. Done. All right, let's look at example 5. All right, we know that point M is between point N and point O. If it's between, that means that we can use the segment addition postulate. Okay, the 2 smaller pieces on the segment add up to the whole segment. So we have to find, we're going to find X and then we're going to find MO, the measure of segment MO. So first, we have to start with all the stuff they gave us. So NM, the length of NM is 17. Okay, the length of MO is 3x minus 5. Okay, and then the measure of NO is 5x plus 2. And how do we know that? Well, they gave it to us. It was given. Okay, next. They told us that M is between point N and point O. So we can use our segment addition postulate. So we know that NM, the measure of segment NM plus the measure of segment MO has to equal the measure of segment NO. That is the segment addition postulate. If I start going too fast, don't forget that you can pause me. Okay, next, I have to do all of my little substitutions. Okay, so for NM, I'm going to put in 17. For MO, I'm going to put 3x minus 5. Bring down the equals. For NO, I'm going to substitute in 5x plus 2. That's the substitution property. Okay, I've got things that are combinable. I have a 17 and a minus 5. Okay, I know that 17 minus 5 is 12, so I'm going to substitute in a 12 for 17 minus 5. So 12 plus 3x equals 5x plus 2. That is the substitution property again. And here we combined like terms, so you can put CLT in parentheses. Okay. I want all of my x's on one side, so I'm going to subtract 5x from both sides. Okay, that gives me 12 minus 2x equals, cancel, 2. That was the subtraction property of equality. Okay. Now I want all of my constants on the right, so I'm going to subtract 12. Okay, so I have a negative 2x equals negative 10. That is also my subtraction property of equality. Whoops. Equality. Okay, last but not least, I have to divide by negative 2. That gives me x equals 5. That was my division property of equality. Okay, make sure you write out all of these steps because there are a couple proofs on your assignment and you will need these as examples to follow. Okay, let's see if we were supposed to plug x in and find any links. Oh, sure enough. We have to find MO. Okay, so we know from the picture that MO is 3x minus 5. So the length of MO equals 3x minus 5. I feel like I might have said plus 5, but I meant minus 5. So sorry if I messed that up. We just found x. X is 5. So I'm going to plug in the 5 for the x. That gives me 3 times 5 minus 5, which is 3 times 5 is 15. Take away 5 is 10. And now I'm done. I'm going to write it off here neat to the side. So the measure of segment MO is 10. That's the end. You made it.